Now let us understand the definition of the ubiquitous computing. It is the most profound technologies or tools that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. This is the definition made by Mark Weiser for the ubiquitous computing. Now, in this practical, we are going to see how the human-computer interaction is going to happen, what are the areas, what are the themes, and what are the challenges, and how we are going to implement this practical accordingly. So, if you want to understand the concept of ubiquitous computing, so you should say like this: it is the beyond of the desktop machine, or it is beyond the desktop computing, and the computer itself is embedded as an environment everywhere in the environment, and it works as a particular environment or particular thing. Means, for example, suppose if you want to make the navigation system for our college, okay, I will draw something over here. This is the boundary for which you want to work. Okay, so let us consider that this is the area of our college. Okay, here the main entrance is over there for the main building. Here you have the entrance for the commerce building, and here are some departments in the commerce like microbiology. Some commerce departments are over there, mathematics department is over there. Here, when you enter into the college, you have a principal cabin and the office over here. Here you have physics department, and as you go on here, here you have computer science department. Okay, now if you want to go uh, from computer science department to physics department, how will you go? You will go like this. This is a path, or you will choose some internal path and then go like this. So in this way, I'm going to reach to the physics department. Okay, when you are trying to find out the nearest path, this path will come as an output because it is the shortest path. Okay, now if you want to go to the microbiology department, if you go to the mathematics department, you can go like this. This is the road map, and here you will reach to the mathematics department, or you can go like this. This is the internal way, like this. Okay, the distance will be calculated accordingly, and the shortest distance will be written as a output, and this is your navigation system. Now if you want to build a navigation system, then there should be a proper unit and the proper scaling. Means, for example, if the distance between physics department and computer science department is 1 kilometer, okay, if the distance between physics department and computer science department is 1 kilometer, and if you are showing it with a straight line like 1 centimeter, and the distance between CS department and mathematics department is 4 kilometer, okay, it is somewhat 4 kilometer. And for 4 kilometers, whenever you're drawing the line, suppose this is the shortest path, it should be of size 4 centimeter. Okay, it should reflect the entire environment. It is not like that. The distance between physics and CS is 1 kilometer, so if you are showing it by 1 centimeter, and the distance between the CS and mathematics is 4 kilometers, and you are again showing it with the 2 centimeters and all. No, this is not a proper way of representing the data. Whenever you are representing the data, there should be a proper unit and the proper scaling. Now just see here, if you are drawing the direction, this is the north direction, this is the east direction, this is the west direction, and this is the south direction. The mathematics department is almost, you want to travel first at the north direction, then you are supposed to travel to the east direction. Okay, so you can say like this is the exactly at the east part of your system or east part of your organization. So whenever you are showing it on the diagram, it should be always on the east part. You cannot show mathematics like here and like here. Okay, there should be a proper position, there should be a proper coordinates for that particular system, and therefore you are going to represent or you are going to display the environment in your computer. And this is the difference between the ubiquitous computing and the normal computing. In normal computing, if you want to travel, through, see, the traveling is the exactly example of the ubiquitous system. But if you want to do some actions, or if you want to perform some uh, algorithms, then if you are not considering the directions and if you're not considering the actual units, then it cannot be ubiquitous system. So this is the basic part of the ubiquitous system. Okay. So for this point, I have represented like this: a computing is embedded everywhere in the environment. So you are supposed to think everything as a computing. How you are going to deal it, that should be deal like a computing system. Then suppose if you have the one more example is over here. Suppose if you have the internet kitchen. Okay, if anybody wants to enter over there, uh, that particular activity should be done automatically, like some cooking appliances will be on automatically. If you want to do some recipes, that will be downloaded automatically. Means suppose if there is a Monday and if you want to do something XYZ, the recipe for this XYZ will be downloaded to your device. Okay, if you're forgetting to do this something, if suppose if in a recipe there are n number of steps, and if you're forgetting n minus second step, then that should your device should remind you that, yeah, you have to perform like this, you have to do like this is the case. So this is all about the internet kitchen. Means how you're going to work in a kitchen, that should be controlled by the computer, that should be stated by the computer. Likewise, the now the intelligent refrigerators are over there. When you're doing putting something into the refrigerator, and the climate control is almost automatic. Okay, so now the things are in market, and how you're going to use that is depending on that particular user. Okay, now some notions are there. Now these are some examples, and from this example we are going to perform the simple practical. This is a simple practical. What is the notions? Like the computing capabilities, anytime, any places. You should have the invisible resources, and the machines sense users' presence and act accordingly. Means, for example, you don't have the recipes, you don't have the ingredients for that particular recipe. Still, it is going to suggest it. Means for any recipe, the ingredients are treated as a resources, but you don't have any resources, but the recipe has the resources, therefore it is the invisible resources. Now the computing capabilities, it should be according like this. Means suppose if there is a good cook, so the recipe should be according to him. If there is a somebody who is trying to do for himself, is not a good cook, so he should not the recipe should not so much complex. Means it should be some like simple recipes should be over there. And yes, whenever you are going to enter into the kitchen, then only the recipe should be suggested. Otherwise it will be of no use. Means suppose if there is a morning 6 a.m. and at the 6 a.m. you are getting some recipes, okay, you can have those recipes, but if you are not in home, that should not be suggested. Okay, so if it is suggesting, that is not a problem. But there is a system which is working for it. For every system you need the internet connection, for every system you need the electricity connection, and for this is considered as a primary resources. So if you are not into your house and still it is suggesting the recipes, then what will happen? It will be the wastage of the resources. So machine should sense the presence and it should act accordingly. So there should be a proper human interaction with the system, therefore it is required. The ubiquitous computing is going to suggest itself. You don't need to input anything. Okay, you just need to input what you want, but itself, beside what you want, what he will do, he will sense the persons and he will act accordingly. As examples like this. Now these are the themes: the automated capture of the experiences with easy access, context aware sensitive interactions and applications, ubiquitous services independent of devices and platform, and natural implicit interfaces. Now just see here, there should be the automated versions. Means that there is a concept like a virtual reality and the augmented reality. In virtual reality, everything is a virtual. You don't have anything as a real part. But in augmented reality, you do have a something as a real part, and based on that real part, you're getting some imaginary part, okay, which is not in that particular real part. So and it is being automated whenever you're looking at this thing. Means, for example, suppose if XYZ person has given you a gift, suppose it is a laptop. If it is given as a gift from your friend, so whenever you're looking at that laptop, you will remind of that friend, you will remind that particular moment. It is not written on that particular laptop, but you will remind that, yeah, on this 1st August I got this gift as my birthday gift. So this is what you are remembering in your brain. The same thing whenever you are going outside, and whenever you are just looking at the thing, if you don't know something, you are going to focus your mobile on that particular thing, and you will get the results. Okay, it should be the context aware, context sensitive interactions, and all these things should be there. Now the ubiquitous services should be independent of devices. Means from a normal phone, you should able to know what to do for the troubleshooting the iPhones. Okay, there are so many videos and there are so many applications. So the application may be installed on any devices, but from that device you should able to access, or you should able to handle the other device. So there is a thing that it should be independent of devices. This is the basic concept of ubiquitous. It should be available for everybody, and it should be available to everywhere. So this is a fundamental thing for the ubiquitous computing. And definitely you're going to imposing the network, you're going to imposing the environment. Therefore it should have the natural and implicit interface. Now just see here, there are some projects also over there. You can take it as an MSc part also. So the automated capture means, for example, suppose you are finding out something you're going to travel somewhere and you're just clicking the photographs. Those photographs were not blur, were not good, or not. There are so many photographs that are of no use. Then you're going to delete it. Okay, that is for just clearing the memory purpose. So when you are capturing the photographs, and if it is coming as a blur, it should be discarded automatically. This is also taken as a project also. So whatever you want to do, whatever you want to do as a brain part, that should be done by the computer. Okay, live board is another application that now if I want to explain something, so what I will do, I will just speak out the accordingly, the examples will be displayed on your board. Okay. Now, what are the issues? Definitely, the internet connectivity is the issue. So the Steam integration that should be done. How much details that you want to embed? How much details you are going to take? That is a different thing. Modifying the record is itself is a fact, because whenever suppose there is a one developer and if you displaying something, it should not. The chances uh, around the getting correct information is equal to 100%, but it is not exactly 100%. So there is chance for the modification, and that should be done accordingly. The network interaction should be there, because if you want to update the data, there should be the network interaction. The context aware computing. In context aware computing, the computing services sense aspects of environment. So it should be based on the location. Okay, means if you are going to Mumbai University, so there is computer science department over there, and also the microbiology department is also over there. So the path should be according to Mumbai University. It should not be according to Gupta College. And when you are into the Gupta College, the path should be according to Gupta College. It should not be like Mumbai University. The distance should not be like the Mumbai University. Means, for example, the distance between this computer science department and microbiology department is around this 5 kilometers, and here we have only 2 kilometers. So it should be like this. When you're in Gupta College, the distance should be 2 kilometers, and when you're in Mumbai University, the distance should be 5 kilometers. So it should based on the location, it based on the user emotions. The user emotions here, the walking speed can be treated as a user emotion. Okay, the user input is treated as a user emotion. If you're walking slowly, the distance might the actually distance time will be something 15 minutes. If he's walking fast, so distance time might be 10 minutes. It depends on the user. So you have to sense the speed of the walking, and according to that particular speed of the walking, you're going to get the distance. Okay, so these are the examples. I will share this PPT. The augmented reality is one more part. Suppose just I told you that if you want to know the information regarding to some particular thing, just move your mobile on that particular thing and get the output, whatever you want. Ubiquitous services. Just I told you like navigation system is the example of ubiquitous computing. Now the natural and implicit interfaces, the pen input, speech, gesture, tangible interfaces will be treated as an input. Even whenever you are now just I have taken the example of navigation system, so I will focus on this navigation system. Whatever map you are going to include as a navigation system, that will be treated as your natural input, and you will be working according to. Okay, the gesture pointer. Gesture means you whenever you're moving your hand. Okay, so this is your gesture. When you're moving your hand, when you're moving yourself, that is treated as a gesture. Okay, now this is one like a personal ambient displays. What is it? They are very small physical devices. Want to display information to a person in a subtle, persistent, and private manner. They can be small enough to be carried out in a pocket, worn as a watch, or it can be around like a jewelry. Okay, now what is this? A display means there should be something to display as an output. Okay, uh, see, this is a path. This there is a path between two departments. How you're going to sense it? There should be some voice output, there should be some visual output. To get that visual output, you need the personal ambient display. It might be a very smaller like a jewelry, or it might be larger like the laptop. Okay, now the pins. What is the meaning of pins? It is an interactive interface. Okay, it is conceived as a computationally enhanced membrane coupling tactical kinesthetic input with the tactical and the visual output. For example, suppose if you don't have the location sensed, now if you want to sense the location between the physics department and computer science department, you can drop the pins. So this is our area. Okay, and this is computer science department, and this is your physics department. And if you want to connect those two departments, so I will go like this, fine, or I can go like this. So I can drop the pins. First pin will be dropped over here, so it will connect like this. Second pin will be dropped over here, so it will connect these two portions. Third pin will be dropped over here, and the fourth pin will be dropped over here. There will be one more pin. Now these two devices will work as itself as a pin, so there should be one pin between them. So this device and this device will be connected, and this device and this device will be connected. So this is a working of a pin. It will work as a tactile or the user input based on the requirement. Okay. Now I will not focus on this landscape. It is again the tangible interface, and when you are getting into theory, you will get the actual idea. The wearable computing, you can wear the devices. Okay, just see here the man has worn the spectacle. Okay, so it can be a ubiquitous devices. Fine. Now let us focus after getting some primary knowledge based on this concepts. Now let us focus what you want to do as a human computer interaction. So demonstrate a human computer interaction. So here you will need to interact with your computer with three parts. The first part is a keyboard part, the second part is a mouse part, and the third part is the Windows itself. So Windows actions will be treated as an output also. So for connecting with keyboards, you will use the keyboard listener. For mouse, you will use the mouse listener, and for Windows action, you will use the Windows listener. Okay, and here there are n number of methods that you have studied while studying the Java, because we are going to implement this practical in Java. So there are methods. I have written some methods for the window listener. The window is activated. Whenever the window is been activated, it will call this method. Whenever the window close is called when window is closed. Whenever you are closing the window closing method will be called. Whenever you are deactivating the window, it should be like deactivated will be called, and the rest three methods will be called accordingly. So let us focus on the practical here. Board listener. Okay, the first practical or the first program will be regarding to the keyboard listener. So just see here, I have imported two statements, java.awt.star and java.awt.event.star. Then this is the class name. It is going to extend the frame, implements key listener. I'm taking the label or text area to display the output. Okay, in constructor, I'm going to call or define the size and layout, etc., etc. Now these are the methods. In key pressed, whenever you're pressing the key, the key pressed will be called. It will be displayed. Key released in method, whenever you're releasing the key, it will be displayed like this. And key type, whenever typing the key, it will be displayed like this. And in main function, I'm going to call it. So let us run this practical and see the output. Okay, now I will compile this program. I don't have any error. Now I will run this program. Let's see, I'm typing the key. Key is typed, key released. Whenever I'm typing the key type is being called. Okay, and the pressed is accordingly. Fine. So this is your output for first part. Now let us focus on the second part. The second part is regarding to your mouse activity. Here you are going to implement the mouse listener, or you can implement the mouse motion listener also. The same thing, you can extend the frame or you can call the frames like here. And here you are calling the methods mouse pressed. If it is pressed, that will be displayed accordingly. The mouse released, if it is released, then it will be displayed accordingly. For mouse exited, if you are exiting the mouse, that will be displayed. Entered, the same thing will be displayed. And if you are clicking something, then the mouse click will method will be called. So let me run this practical. No event, I'm just clicking. Okay, whenever you're entering into the frame, it is called as a mouse entered at a point, mouse exited through point. Okay, you can click. Okay, mouse click like this. Fine. This is about your mouse click event. And the last event is a window example. Here you're going to implement the window listener. The rest things are same, and you're calling the methods. In the window activated, that will be displayed as activated. But here you want to display at the console. Therefore, it is written with the system.out.println. If it is closed, then close. If it is closing, then closing. If it is a deactivated, then deactivated. If it is a de-iconified, then same. Let me check the output. Just see here the activated O point. Now I will close, deactivated and closed. Okay. So for